From my Data Intelligence Launchpad, let's navigate to the Machine Learning Scenario Manager. You see I have several scenarios here. I will enter into the latest one. And as you can see, the scenario is a place when you can collect different resources related to the same business case. Here we have the notebooks that we can use to develop and tune our machine learning models. And then we have the pipelines that are useful for deployment. Let's open a notebook and have fun with some machine learning. As we have said before, we will work with a dataset of books and we want to cluster these books, meaning we want to find groups of similar books based on a brief textual description associated to each book. We start by making sure that we have all the libraries that we need. We will use some very common Python libraries, plus a couple of libraries for the text preprocessing. And Jansim is an open source library that provides the word embedding. Our input dataset is stored in HANA Cloud, so here you see I'm also installing on HANA ML. In this example, we will use it only to pull the dataset from HANA Cloud to our Python client. We will not use any of the HANA ML libraries here. So let's connect to the HANA Cloud instance and load the books table in an HANA data frame. Then we use the collect method, as we have explained in the previous demo, to pull this table in a pandas data frame. So now all the data are loaded in memory in our Python client, and we don't need the HANA data frame anymore, so we can get rid of it. I will not go through all the details of the code here. You can find the notebook in the workshop material and you can check it out after the session if you're interested. In general, we will stay focused on the description field for our analysis. So the first step is to tokenize the text. So this is the piece of code that does the trick for you, and here you see the output. So we removed punctuations from our description strings, as well as words that did not bring any useful semantics, etc. Then, second step, we need to transform the description string to a numerical vector. So let's download the open source model to do that, glove, and apply it to our tokenized sentence. So this will take a while, so let's fast forward here for a few minutes. And here is what we get. Each book has been mapped to a specific point in a 100-dimensional space. Now we are ready to group our books together based on their distance in this multidimensional space. We will use a k-means algorithm taken from a Python library called scikit-learn. I'm sure the one of you that have a little bit of experience in data science know what I'm talking about. If you don't, no worries. I would just like you to understand what is the overall flow here. So we can call this k-means algorithm, and we say that we want 10 book clusters in total. And once the algorithm is done running, it has assigned each book to a specific cluster. So let's see if we can qualitatively understand if it worked. So let's print out a few descriptions for each clusters. So for cluster 0, the topic seems to be related to teenage fiction, friendship, family. Then we have cluster 1, probably more about fantasy. Then if we scroll down, you can check out the cluster content by your own at home. But anyways, we have a cluster that it's more about history, social life and customs, that is cluster 7. And then cluster 9, for instance, mostly animals, etc. We can also try to use some so-called dimensionality reduction techniques to try and visualize our books laying in this multidimensional space with 100 dimension. So I will use something called PCA and TSNI to project this huge multidimensional space into a simple 2D box. So here in this plot, each point represents a book, and books with the same color were assigned to the same cluster, so they share similar descriptions somehow. So you see that there are clusters that look nicer than others, so more dense, more well-defined. There are some other clusters that are more spread out, so maybe the description there is maybe more generic, not well-defined, not easy to analyze, but in general, say we feel quite happy. So what we need to do before closing the notebook is saving our model. So we can take the Chemis object that we have built and we save it to an artifact so it can be used later on to score new descriptions. So in case the book owner wants to expand his inventory, he can use this artifact to determine which clusters the new books should be assigned to.